Okay, good afternoon, everyone. Thanks for coming to tutoring. Obviously, you're here to review for your quiz on Monday if you're an odd student, or tomorrow if you're an even student. Is there a particular topic you want me to start with, or just review everything?
Should we just review it?
Okay, because I did a review in class already. Do you remember that? It's basically the same. I'm gonna do the same thing again.
Yeah, can we go through it like the questions?
Sure, I can give you random questions and you try to solve them.
I need to
Explain what?
everything.
Like from the beginning? Like you were not here when I taught it?
Percent composition.
Okay, I can teach percent composition, but did you watch the YouTube video on empirical and molecular and that you're fine with?
Yeah, I can't really like learn on my own because I watch it and I
Okay, well, I mean, I didn't teach it in class and it's there available for you to watch it and learn it. So can I reteach it here in tutoring? Yeah, but I prefer to go through practice problems with you than me teach it again because most of us already here know it. It's just more reinforcement. So what I'm going to do is I'm just going to give random problems, okay? Huh? Do I have a periodic table? Do you have a periodic table? Under your desk, there's a textbook. The very last page of the textbook is a periodic table.
The same?
Huh?
Are these
No, they're not the same. They're not rounded, but it's fine. Okay. So, I'm going to make like a little study guide of all the information you should know. And then we'll do random problems together. I'll review percent composition, practice on it, review mole conversions, practice on it, and then review empirical molecular, practice on it. Cool? Okay. So let's start off with the mole conversions. So, let's do... Okay. Okay, mole conversions. There are 6 questions on mole conversions on the quiz. Okay? So the first thing that I want you to do when you take this quiz is to draw out this map. Okay? This is great if you get confused when to use 2 fractions or 1 fraction in a calculation. So this map will help you with that. How do I know if I need 2 fractions or 2 conversions versus 1? This map will help you with that. Okay, before I even discuss how to use this map, can you remind me what RP means?
Representative.
Beautiful. Can you tell me the 3 types?
Atom.
Molecules,
Amazing. Atoms, molecules, and formula units. Beautiful. Okay, how do I know which one to use in the problem?
the single element is an atom.
Right, so it depends on the substance.
Yeah.
If my substance in the problem is a single element, yes, I use atoms. What if my substance is a covalent compound with 2 nonmetals? Nice. If my substance is a nonmetal and a nonmetal, it's covalent compound, it's molecules. And then formula units,
Oh, they're safe.
no, and then formula units,
No.
ionic when I have a metal with a nonmetal or a metal and a polyatomic, just, metal in there.
Wait, covalent to non-metals?
Yes. Any questions on this so far? Okay, so every time in a problem, I will give you what you know, so the known, and I will ask for the unknown, right? What I know is where I start. That is always going to be the number given to you in the question. Yes or no? Perfect. So if I know grams, I'm given grams, and I am looking for moles, that's my unknown. How many steps should my problem have? How many conversion factors? Good. From grams to moles. From grams to moles is one step. So I will only use one fraction in my problem. Yes or no? Yes. Okay. Let's say my known is still grams, but now I'm looking for atoms. How many steps should my problem be? 2. So from grams to atoms. That means grams to particles. Again, which particle? Atom. So that's 2 steps to get there. So 2 conversion factors. Just keep that in mind. Okay, what are the only 2 conversion factors that we are going to come across in this quiz? Okay, Avogadro's number is one of them. So 1 mole is equal to what? Do you know Avogadro's number by heart?
6.02 times 10
0 2 times 10
And what's the unit for Avogadro's number? Unit.
Good afternoon, and pardon this interruption. Will all teachers of Michael Church please report to the counselor conference room? All teachers of Michael Church, please report to the counselor conference room. Thank you.
Okay, it can't be moles because I have 1 mole is equal to this many moles. Does that make any sense? No. Grams is different. That's molar mass. Okay, representative particles is the unit for this, Avogadro's number. So if you get confused when I put RP, just think of this. It can be 6.02 times 10 to the 23rd. It can be 6.02 times 10 to the 23rd molecules, or it can be 6.02 times 10 to the 23rd formal units. It can be any of those 3. Does that make sense? Okay, the other conversion factor we have is something called molar mass, where 1 mole is equal to a certain number of grams. Okay, this grams number can be found where? Yes, PT means periodic table. What's the unit for molar mass? So again, this is molar mass. Grams per, do you see? Grams per mole. Or mole per gram, but it's really written grams per mole. This is a bonus question on your quiz. Or I ask you what the unit of molar mass is. What would you say? Grams per mole.
Wait, what was the question if you would ask us?
What is the unit for molar mass? Only 2 conversion factors that we use for these problems. Only 2. Okay, very simple. Okay, so let's do some examples of this. Number 1, we're going to convert 8.3 moles of sodium chloride to grams. Okay, again, in dimensional analysis, I'm going to make a little note box over here. Okay. And I'm going to say setup. Given times a fraction. Right? Okay. Unit you want goes where? On top. That's why I'm writing it there. Good. And the unit given goes where? At the bottom. Unit. Not the number. Just the unit. Okay? Keep that in mind. What is my given in number 1?
8.3 moles of
Beautiful. 8.3 moles of NaCl, sodium chloride. And I always multiply by a fraction. Perfect. Always. Okay? According to my setup, what goes on top? Good. What is the unit I want? What is the unit I'm given? Perfect. So that will go on the bottom, right? Okay, look. I have grams per what? What is that? Thank you. So I will use this conversion factor and plug that into my formula, into my fraction. I'm not going to use Avogadro's number. What is Avogadro's number's unit? Atoms? Or do I have any of that here? So I cannot use this number. Does that make sense? My numbers, my unit is grams per mole. I have grams and I have moles. Out of the two blue things, which one uses grams? The bottom one. So I must use molar mass. How can I find the molar mass of a compound?
You find each and you add it.
Good. You find each mass on the periodic table, you add it up. What is sodium?
22. Well, it's 23.
Yes, we round that one to 23. Plus, what's chlorine's molar mass? 0.45. Okay, there are only like 5 of them that you actually round. The rest you write exactly the way you see it on the table. Yes. Hydrogen. It's very simple, I promise. Hydrogen is just 1. Look on the periodic table. What does it say for hydrogen? Okay, we're not writing all that, so we're just going to say 1. Sodium, what does it say on the periodic table? 9. We're not writing that 9. Unnecessary. We're putting 23. What does it say for carbon?
12.0.
Don't care about the 11. I'm just putting 12. You get me? Nitrogen, what does it say for nitrogen?
It's 14.
14.005. We don't care about any of that. Okay, again, I'm just putting 14. Oxygen
16.
is 15.999. I don't care about that. Good, so yours is good. That's the one you're going to get for the quiz.
So the one we're getting for this already not.
No, it's... Okay,
Oh, okay,
You have to
these are not.
Okay, I got it.
These ones are not. Only oxygen and fluorine on that one is rounded. Yes, there are technically rounded, but there's 4 of them that are not rounded fully to what I want you to use. Fluorine is already 19 on that table, right? Okay, so this is the masses that you will use. So I took sodium is 23. What is 23 plus 35.45?
58.
Thank you. Grams per mole, because this is molar mass, yes? Again, grams per mole. That's written right here. So where's this number going to go, on top or bottom? Top. Because what does it say? 58.45 what? 58.45 what? Per fraction, 1 mole. Does that make sense? Fraction. Does that make sense what I just did? Good. Okay, if the number that's not 1 is on top, we multiply. But make sure that my units do what? And I'm left with who? Is that what I want in the answer? Great. So I'm finished. I just have to do the math. What do you get when you multiply these two numbers? Say it again.
485.
Like that? What'd they put? 0.08? 0.04? Did they get 0.0357 at all? Hi.
Can we still start these, or are we good?
I need it tomorrow though. I don't. Yes. Okay. Thanks, guys. -1. Okay. Good. Everyone got this in their calculator, right? Okay. So then what's my final unit
Grams.
of?
NaCl.
Nice. My moles canceled out. There's no moles there. How many sig figs should I have? Yes. Not done yet.
4.
Why 4?
Oh wait, no, below this and 2.
Good. Where's the second sig fig?
8.
Can 5 round 8?
Yeah. So 49.
Yeah, but can I round 485 to 49?
No.
What is it?
That's just 490.
Beautiful. Does that make sense what I just said? Anyone confused? Everyone's good? Okay. Next. We have problems with this. Like, what do you think is your guys' weakness? The empirical molecular stuff, the percent comp, or this? You're answering all my questions though, so I don't see.
But that one was easy.
I think it's an empirical one.
Okay.
Maybe if we do one that has two.
Yeah, we'll do it.
fractions.
Okay, and also you could have looked at the map. So we're going from moles to grams. Moles to grams, how many steps? Just one, so I have one fraction. Okay, next. I'm testing for math. Like I'm doing a topic test tomorrow. I'm gonna tell her. You're right, I'm not testing. Hi, lovely. You're right, I'm not testing for fast, but I am testing for topic 8 and 9 tests. Okay, fine, no, you're good. I'll give it to them, the test, what, next week? Okay, perfect. Yay. All right, love you. Bye. Have at it.
Leave it.
No, take it. Okay. Convert 2.25 times 10^23 representative particles of calcium carbonate to grams. Okay, first of all, again, let's look at my map real quick. Where am I starting? Beautiful. How many types of representative particles are there? Which one do you think I'll be using in this problem? How do you know that? Why?
Because there's a number.
Beautiful. Okay, I can't just say representative particles and put that as my unit. No. Again, there are 3 types of particles. There are 3 types.
If you're getting studying with
The unit is wrong, it's partial credit. Okay, I want you to think of this. What are the 3 types again? Yes. Good. Okay, what if I asked you, what are some for length?
foot, meter, foot, inch, centimeter.
Foot, inch. Do you understand what I'm saying? Do you understand what that means? Okay, good. So it's equivalent. Like, you can't just say, oh, convert 2.25 length to no, it doesn't work that way, right? I have to specify a certain unit. Same way that it works over here. I have to specify one of these units. And the way that I do that is I look at the substance. Okay, calcium carbonate is an ionic compound because it has a metal in it. Calcium's a metal. Because there's a metal in it, it's ionic. Therefore, I use formula units as the unit. Yes?
What if you put the unit but not the compound or element?
As like the final answer?
Yes.
Like you're saying 490G without the NaCl? That's fine. Yeah, but in stoichiometry, we'll be dealing with multiple substances at once. Huh?
Are we doing that this year?
Girl, the PowerPoint is due tomorrow. The notes for that is due
But
tomorrow.
that's in stoichiometry?
Yes, that's the title of the PowerPoint. Okay? So yeah, we're gonna be diving deep into stoichiometry. I'm not gonna have time tomorrow because of the quiz, but next class after that. And we're gonna be dealing with converting this, but multiple different substances at one time. So that's why I make you specify what substance. Okay, so what particle did you guys say again I'm using? Good, so I'm not gonna put RP, I'm gonna put formula units, yes? It's okay. So I always start with what, guys, according to my setup?
The one you want.
Let's give.
Good. Well, I was with my given,
Yeah.
which is what?
2.25 times 10 23 40 units.
Formula units, right? We specified formula units of calcium carbonate, and I always multiply that by a fraction. What am I looking for here?
Oh, grams.
Grams. So pay attention to this part, please. Look. What am I starting with? What am I looking for?
Grams.
What am I starting with?
Centimeters.
What am I looking for?
Grams.
How many steps is that?
2.
2 steps. So where am I going to go first? So where's that going to go if I'm looking for it?
The top.
Good. And what goes on the bottom? Nice. Look, Moles, formula units. The other one was grams in mole. I knew that was molar mass. So what's mole in formula unit? What conversion factor are we using? Top or bottom? Right. Avogadro's number is what we're using, yes? Again, Avogadro's number can be what units? Which one do we have? So we're going to put his number with the formula units. Does that make sense? We're going to put his number with the formula units. We're going to put his number with the formula units. Does that make sense what I just said? Okay, and this is equal to what? This is equal to what? One what? Beautiful. So that goes on the top, right? Good. Okay, what happens to my formula units? Good. I'm left with what? Do I want that though? What am I looking for? So I need another fraction. In this fraction, where am I going? Right. So again, we were here. We just went to moles. Now we need grams. Yeah, so I'm looking for grams. Where is it going to go if I'm looking for it? Good. So my FU's just canceled out. Who's left over? I need to cancel him out. Bring him to the bottom. Now he's canceled out. I'm left with what? Is that what I want in the final answer? Great, so I know my setup is correct. I plug in my numbers. Grams to mole, mole to gram. What is that unit? What is that conversion factor? Molar mass. So am I going to use the top or the bottom? Right, the bottom. Okay, so how do I get the molar mass of CaCO3? Yup. What's Ca's molar mass? 40.08, right? What? No, we don't round those ones. Remember, the only ones we round are the ones I told you to round. Everything else that you see on the periodic table, leave it the exact way it is. Right. So the calcium is 40.08. Okay, and then carbon is 12, right? We said carbon is 12, yes. And oxygen is what? 16, but there's 3 of them. So 16 times 3 is 48, yes. Add them all up together, what do you get? -7. Where's the answer? For the where's the answer problem? -7. Mark it wrong. Is that the question you were asking? Yeah. I don't know what they're doing there. What do you get? Like this? No. Like this? Okay. And what's the unit for a molar mass? Beautiful. So it's 100.08 what? 100.08 what? Grams. Goes where? With the grams on top. You see that? You see that? Okay. And what goes on the bottom? Good. So now, again, my units cancel out. I'm left with grams. Yes? Good.
Say like how you just how you're doing it in the calculator. I have to say one.
Yes. Depends on the calculator that you have. You have this written down, right? No, it's okay. What happened?
I have to go memorize it.
Oh, okay.
I'll send you the email.
You're welcome. You too. You see this? Yes, you see? Okay, so I'm plugging in this. .25 times 10 to the power of 23. Okay? Times. This is a fraction. I use the fraction button. On the top of the fraction, what is there? 1. So 1 goes on top. What's at the bottom of my fraction?
6.02 times
Okay, get out of there. Times another fraction. 100.08 is at the top, right? And what's at the bottom?
That's and then you drop.
Does that make sense what I just did?
Yeah.
Is it 37.4?
Yeah, well, so, yeah, that's what sig figs, right? How many sig figs should my answer have? Yeah, 3. Beautiful, exactly.
Because of the 2.25.
Right, because that's the smallest amount of sig figs in the problem. And 6.02 also has 3 sig figs.
If you use another calculator, do you multiply the formula unit by the grams?
Yeah, so
And then
multiply the
divide it
top.
But what about 100.08?
So you're going to multiply the whole top first.
For sig figs,
That's 5 sig figs. I want the smallest number in my problem,
Okay, so
in my answer.
You can multiply the formula unit with the grams and divide it by the.
Yes, but I need to put it in parentheses if I do that. 2.25 times 10 to the power of 23, and I'm multiplying that by the 100.08. And that doesn't have to be in parentheses, only the scientific notation. Then I divide that whole thing and divide it by the bottom number. Again, that's a scientific notation value. I need to put it in parentheses or it's going to mess up my calculations. Same exact answer. Yes. What is that? For what? What? Huh? Oh, I have no idea. One second. Okay, so do you see that? How I just did that? Okay, so our final answer, like Brooke said, was 37.4 because of the sig figs given in the problem. It's grams of calcium carbonate. Yes or no? Beautiful. Does that make sense? Okay, I want you to do this one by yourself, please. Do it by yourself. Wait, Jazz, these last 3 are 5 points. Not 7. But yeah, they got the wrong molar mass. So how did they get the right answer?
That's why.
Yeah, no, I know.
So, like, a lot of kids have had that same thing, but I never actually.
Where they had the wrong molar mass and the right
That doesn't make sense.
how many of them have that? Mark it wrong. They don't have the correct molar mass?
Everything.
Means they're copying somebody's paper. I'm just gonna mark it wrong. Here you go.
Like, this one has 298, but they got the right answer.
And the thing is 294? Okay, when they plug 298 in the calculator, it gives you a close answer or what? Again, everyone should be trying number 3. And then and then I have to, move on to the next topic. Because it's already 3 o'clock.
It's kind of close, but it doesn't give you 7.
What does it give us?
It gives you, like, 0, 3, 5, 2, 3.
But they put the 7.
Yes.
I guess half credit for that one since it's very close. The other one was not close. It was 244 for the molar mass, but they got 298 for the molar mass. So maybe just give them minus 2.5 because half credit. Tell me when I can go over it.
We're not
Mm-hmm.
Is that covalent?
I don't know. You tell me. Hey, what makes something covalent? What does it say right here for covalent? Good. And what does it say for ionic? Good. Okay, so you need to know if this is a metal or not. You can do that by looking at the periodic table. And you hopefully you remember chapter 6. Which one's the metals, which one's not. It's important to know. Hmm? What do you mean? Do you know where the metals are on the periodic table?
No.
So you see you have a textbook under your desk? Take it out real quick. Open to the very last page of the book. Not even page. Very last. No, before that. You see all the yellow elements? They're all non-metals. The blue ones are metals. So look at MgOH2 and see, are any of those metals? If MgOH or 2 is a metal, it's an ionic compound. Because ionic compounds contain metals. Yeah. Either one is fine. The periodic table that she has is one you're getting on the exam, the quiz.
What are the exceptions? There's ones that are
These ones. Can I do it?
Wait, I'm rounding it.
I did the beginning right, but then just when it comes to the second
Let me see.
conversion, the second fraction.
Who do you think is the better chemistry teacher
They say I'm stuck.
between you and Saint?
Let me see, do it.
They say
Okay, I think I got
No,
it.
no, no. Wait.
I don't know. What did you get?
Let me give you Let me give you guys a few more minutes.
You got two.
Because I forgot how to.
Wait, do you know
कुछ
the
नहीं से परेशान है
Okay, what's the answer? Because this time we're not gonna.
I don't know. I'm about to solve it with you.
You don't have it in front of you?
No? I make up these problems off the top of my head.
Oh, yeah.
I make up these random numbers.
What's the problem?
I know.
I can tell you the answer. Give me 30 seconds. Can I do it now?
What's the thing for numbers?
24.31.
No, how is Lisa's presentation?
Okay. Ready?
Just say
Yes.
in a fraction, if you start with grams, would it be mole?
What do you mean?
Like
It,
in this instance, it would be like at the bottom of the fraction.
I'm starting with grams, so grams go to the bottom of my first fraction.
But
Yes.
It would be mole, or would it be grams?
What do you mean? Would what be grams? The bottom or the top?
The bottom. Like
Yeah, I'm canceling out grams. It must be at the bottom. I'm looking for goes on top. I'm not looking for grams. I already have it.
But would the unit be mole for grams, or would it just be grams?
What does that mean? Because you're asking me, this is what you're asking me. Nicholas, would the unit for centimeters be inch? Will the unit for inches be centimeter?
No, because the formula says 1 mole equals how many.
Okay,
Yeah,
yes.
so would it be
So,
58.31 formula units
no,
over
no. 58.31. Where'd you find that number from?
adding the
Okay, adding the what?
atomic mass of the
Masses are in what unit?
You have the hints already?
Okay, what's weight? Grams.
Hey, did you do
What'd you get? I'm doing it.
I got 2.18 times
This is what I got.
No, you didn't get that. What'd you get?
2.18 times
I didn't get that. What'd you get?
1.9. What?
All of you got different answers than me.
What's the mole
I
mass
got
you use?
2.034.027
Close.
Times 10 to the power 10b.
Mm-hmm.
What's the molar mass you use?
58.31.
58?
Why
There's 2 oxygens and there's 2 hydrogens in the formula.
Bro, wait, what if
So
Ah.
I'm not even gonna lie. I did add the decimal in my head, and I don't think that was like.
Okay. Yeah, I agree. All right, ready? You're watching?
I put 15.4.
I gotta progress with the tutoring, guys. We have 20 minutes left, and I didn't even touch the other stuff yet.
What's the thing for magnesium?
You're right, David. You have it. Look in the textbook right there. Last page.
Can you just tell me
No. Okay. I'm starting with what I know. Yes.
what you know?
What do I know? What's my given? Grams of. Thank you. Okay. Look at that. Look, you're looking. That was my given, right? I take my given and do what with it? Times it by a what? A fraction. A fraction, a fraction. I want you to say that word when I say that. I always take my given and do what to it? Times it by a fraction. Use the map I told you about in the beginning. What am I given? What am I starting with? Grams. What do I want? Particles. Again, what am I given? What do I want? What am I given? Grams. What do I want? Particles. How many steps is this problem? Okay, so I need 2 fractions in there. Where's my first step going to? I cannot go to particles before grams. Sorry, before moles. I cannot go jump. I can't. I have to stop at moles first and then particles. Does that make sense? So I will stop at moles first, which means if I'm looking for moles, it will go on top. The grams that I'm given will go at the bottom. There are only 2 conversion factors, guys. 2. Look at the blue. Do you see the blue words? Okay? What do you see here? Hold on. What do you see here in the fraction? Moles per gram. Which out of the 2 blue things have grams in it? Okay, so I cannot use this. Where do the grams come from? No, you're naming something completely different. I just scribbled out particles. Grams is a different unit than particles. How do I find the grams again? Thank you. Okay? So I need to go to the periodic table for this compound, MgOH2, and I need to find out what the molar mass is. Good. What is the molar mass of Mg?
24.31.
What is the mass of O?
32.
16, but I have 2 of them. This 2 distributes. 16 times 2 is 32. Yes, good. And then I have, what's the molar mass of hydrogen? 1, but there's 2 of them, so plus 2. So what is the molar mass here? Okay, where does this number go in my fraction? Yes, it's 58.31 what? That's molar mass. 58.31 grams per 1 mole, guys. Come on, get it together. You're going to have a heart attack when you look at stoichiometry. You don't know how to do this? You're going to have an actual heart attack. Not even kidding. I need you to master this before we move on. Seriously. Okay, what happens to my grams? Okay. I want moles.
Yes.
I want moles. I want moles is my final answer.
Not
I'm
the
done?
answer, but no.
I'm done though? No. Am I finished with the problem? No. What do I want? Okay. Can I put particles on top like that? Yes. Good. I have to find which particle. It can be 3 things. It can be any of those 3. How do I know which one it is? Yes, it's a metal with a polyatomic in specific, or metal plus nonmetals, meaning this is an ionic compound. So what is the unit? So where's that going to go? I'm looking for what? Formula units. What goes on the bottom? Beautiful. 1 mole. And where does this number for FU come from? We have 2 options. The one with grams or the one with this? Which one should I do? The top or the bottom? Right, because that's our formula unit right there. And what number is our formula unit? Good. So that number will go with our formula unit. Does that make sense? What do you get when you multiply this and divide by 58.31? You get 2.033 times 10 to the 23rd. My moles cancel out. My grams cancel out. I have formula units of MgOH2. How many sig figs should I have? Everyone agree? Everyone agreed to 3 sig figs? Yes. How many sig figs is here? Whoa. How many's here? Here? 3. How many's here? And how many's here? What's the lowest number? So I need 3. Where's the third one? Here's sig fig 1, sig fig 2, sig fig 3. Can sig fig 3's neighbor, can it round him up? No. What's my final answer then? Done. Okay, I'm not going to do any more of this because I don't have time to. Let's move on to percent composition, okay? Okay, for percent composition, there's a formula that you have to memorize. Okay? In order for us to determine the percent composition of elements in a formula or in a problem, I use this formula. Percent composition is equal to the mass of the element divided by the total mass of the compound. And I take this fraction and I multiply it by 100. Okay? There are 2 ways I can ask you this question. The first way is by just giving you straight up formula like this. Let me think of a formula. Hold on. I'm giving you a hard one because you're prepared. Okay, I can ask you the percent composition when I give you a formula, or I can ask you the percent composition when not given a formula. Okay, I can say this. 42.1 grams of alumin react with 16.3 grams of sulfur. What is the percent composition of the compound that is formed? You with me? Again, 2 ways I can ask these percent composition problems.
How many are gonna be able to?
4. 2 formulas, 2 word problems.
Yeah, it's only 6. No, it's 10.
The quiz is 15 questions. There's 6, yes, there's 6 of these. 6 of those. And then I have, for percent composition, 4 questions of these. 2 word problems, 2 formulas. All right, let's start. When given a formula, guys, the first thing that you want to do is find the molar mass of the whole compound. Okay, so you're going to add up all of the masses for every element. Nickel, find nickel on the periodic table and tell me what it weighs. 58.69. Beautiful. But I have how many of them? Yes. In the formula, how many nickels do I have? So I have to times it by 2. Does that make sense? Plus, what is the weight of my sulfur guy? Right periodic table in front of you. 32.07, yes? Okay, but again, look at this subscript on the outside of the parentheses. This distributes, multiply. Distributes, multiply. I have how many S's right now? 1. What's 1 times the 3 I just distributed? 3. So I multiply the S by 3. So the 32.07 times 3. Does that make sense what I just did? Plus, now the oxygen guy. How much does he weigh? Beautiful, but how many do I have?
12.
Yes, 4 times 3 is 12. So I have to times it by 12. Again, you distribute the number on the outside. The number that's right here distributes times by 4 times by 1. It's in a parentheses. If I'm doing math and I have this, how would you solve this? 2 times x is 2 times 3 is, okay, same thing. 3 times 4 is 12. 3 times 1s, 3 s's now. Make sense? Okay. So now multiply, add all of that up together for me. What do you got? What is our molar mass? Calculator, do it.
105.50.
You both got the same thing, both of you? 405? 0.59? Don't round this number. We only round the elements I told you to round, and then when you get your final answer, you leave it. Everyone sees how I got that as an answer? Okay, good. I'm not done. So again, what did I just find? Remember, this is the formula to find percent comp. What are the pieces of the formula? I need the mass of the element, and I need the mass of the compound. What did I just find? The mass of the compound. This is a compound, guys. A compound has multiple elements in it. Yes? I just found the mass of the compound by adding everything up together. That's the total. How many elements do you see in my formula here? 3. Right? What are the elements? Name them. Right? Everyone sees that? Okay? 1 second. Okay? Now, it's asking for the percent for each element. So I need to do this formula 3 times because I have how many elements? Okay? So for nickel, draw a fraction to represent the formula. Draw a fraction to represent the formula. Draw a fraction to represent the formula. Okay? Again, what goes in the bottom of this fraction? Which is what?
405.59.
And I can do that for everyone, yes? What goes on top? The what? What goes on the top of the fraction? According to my formula. Yes, how can I get the mass of the element? Yes, right there. But again, I don't put 58 there. It's 58.69 times 2. So what is that? Bye. That's fine.
How can I get this?
I'll send it to you in the group chat. Or she can send it to you, sure. 58.69 times 2, what is it?
117.38.
Thank you. So that goes on top. Do you understand why? Not this. You have to multiply it by 2 if there's 2, or 3 if it's 3, or 4 if it's 4, whatever. Does that make sense? No? Okay, times 100. Okay, sulfur. The mass of sulfur is this. But how many sulfurs do I have? So what does that give me? My calculator, it says this. Did you get that? And again, I times it by 100. Oxygen is what mass? But I have how many oxygens? What's 16 times 12? 192, and I have to times it by 100. All percent composition problems will get 3 significant figures. What did I just say? All percent composition problems will get 3 significant figures for the final answer. Thank you, Jazz. Sorry, I just want to finish this tutoring session. Amazing. Bye. Okay, so do this one. Do this calculation. What did you get? This one. You guys need to practice doing it on your I'm not going to give you a calculator on the quiz. You need to have one. Noia's the only one who's answering my calculation problems. What's not working? You don't own a calculator?
No, I don't know. I was studying.
Okay. So 117.38. What did you get? Okay, so I'm going to do without adding it, without rounding it first. Who kicked you out of the group chat?
I don't remember.
After class, yes. After I'm done with this recording. Okay, so this is a number straight from the calculator. There's extra numbers, but I don't care for it because what did I say about the sig figs for these problems? Only 3. Thank you. So where's the third sig fig for NI? Good. Can 4 round 9? My answer is? Beautiful. Percent. Make sure you put the percent sign for your final answer. Okay, next. What'd you get?
We got 23.72.
Both of you got that? Good. 23.72%. But how many sig figs again? Where's the third? Can 2 round 7? No. 23 point. Good. Next. 3 what? Okay, again, how many sig figs per percent? Where's the third sig fig? Can this 3 round that 3? 47.3. All of these have 3 sig figs, right? And huh? All 3 of these numbers add up to 91.9? Makes no sense. Oh, 99.9. I said 91.9. I got scared. Sorry. Yes, 99.9. That is perfectly fine. Sure. So the periodic table I give you is rounded. It's not like that. So you're going to use the exact number that's given to you on that periodic table. Except for the 5 that I told you that you round. Does that make sense?
Yeah.
Good. Yeah, no, it'll make your life easier by that. These ones, extra unnecessary numbers that we don't have to use. Do you see how I got that as an answer? Okay, let's do number 2 real quick. 42.1 grams of aluminum react with 16.3 grams of sulfur. What is the percent composition of the compound that is formed? Okay, again, percent composition. What elements are found here? So I'm going to have a percent composition for who? Aluminum and sulfur. I hope you guys know your symbols for this quiz, by the way, too. Good. What's CR?
CR?
Mm-hmm. Okay. Just making sure. Yeah, I'm going to write out the elements. I don't tell you the symbol. I hope you know the symbols for a lot of them. Okay, good. So aluminum. Again, we're trying to find the percent comp. What is my formula? Mass of the element over times? Good. Do I know the mass of the element for these? Or the mass of the compound? Do I know any of that? Just by looking at the problem, do I know?
Yeah.
Which part do I know? No, so which part? If I look at the problem, I just see it automatically without having to do any calculations.
Yeah, 42.1.
42.1
Mass of
grams
the element.
aluminum.
Good. So what does that mean?
That goes on top.
Right. So the 42.1 grams of aluminum will tell me the mass of aluminum, which you guys said was 42.1.
And 16.3
Yep. And then 16.3 of sulfur, that will go to the bottom. Okay, good. How do I get the total mass of this compound? Good. So I'm not using the periodic table for this. Do you see that? Careful. Okay, what is 42.1 plus 16.3? So that will go where? Good. That is my total by adding them together. Times by 100. What's aluminum's percent composition?
72.089.
Good. How many sig figs did we say? Good. Where's the third sig fig? Can 8 round 0? 72.1% is my final answer. Yes? Next, 16.3 divided by 58.4 times 100.
27.910.
Perfect. How many sig figs again? Where's the third? Can 1 round 9? 27.9%. You asked me, I don't want to give it to you. You're getting extra credit for being here.
That's 400. We're done.
We're not done. We still have empirical and molecular formula to cover. You don't have to stay.
Wait, that's
I
true.
thought we were leaving at 3:30. I thought you said that's the latest you could.
I mean, that's when the session ends. Will I get through all the content by 3:30? Depends.
Oh, I told
Then you can leave at 3:30. That's fine. I'm gonna finish the recording and I'm gonna continue with empirical.
Yeah, 3:45.
That's fine. Okay, so let's do that. If you're still here to listen, great. If you're leaving, bye. See you tomorrow. See you. Have a good weekend. Whatever. That's fine. I know I said 3:30, so I get it. Don't worry. But I'm gonna record this part anyway, so you can have it later if you want to watch it. Okay, there's 5 questions on this for the quiz. All right, so let's first of all. So I'm gonna teach it. You don't have to listen to me, but don't talk because again, it's recording. So you're gonna be distracting. You have a question?
No, I just want to see an example to see if they know it or not.
Yes, we'll do one right now. Okay, so for empirical and molecular formula, you have to remember 2 things. Empirical formulas are the simplest whole number ratio of elements in a formula. Okay? Reduced to the lowest ratio. With molecular, on the other hand, it shows the exact number of atoms, or I should say elements, in a formula. So not reduced. For example, okay, for example, from empirical, CH2O. Can I reduce that any further? Can I reduce the numbers any further? How many C's do I have? How many H's do I have? How many O's do I have? Can I divide all of these by the same number and reduce it further to get a whole number? No. So it's already reduced. Okay? Molecular, on the other hand,
Yeah, you can.
Can I divide all three of these by the same number to get it lower? Yes, I can divide all these by what? And what would I get? C1H2O1. Basically that. Does that make sense? So this one is not reduced. I can reduce it. This one is already reduced.
That's it? That's all?
No. Bye. Have a good day. Okay. In these types of questions, you are going to be asked to calculate either that one or that one. Okay, so first, you need to understand one very important thing. You cannot find the molecular formula unless you have the empirical. Okay, so let me just write that. Okay, you cannot find the molecular formula without the empirical. Okay, the questions for this on the quiz will be worded like this. Okay, so this one I actually have to look up an example. I can't think of the numbers off my head because they have to add up to 100. So 1 second. Okay, here we go. A compound is found to contain 40% carbon, 6.71% hydrogen, and 53.29% oxygen. Find the empirical formula. Okay, this is how it's going to be worded on the quiz. Okay, so if it's asking for empirical formula and you see percentages in there, the first thing you're going to do is take these percentages and change them to grams. So what does this become? 40 grams of carbon. What does this become? Grams of hydrogen. What does that become? Sorry. Yeah, oh my god, I can't. There. 53.29 grams of oxygen. Step 1. Easy part, right? That's fine? Again, what is the goal? We are trying to find the formula that contains CHO, and we're trying to figure out, okay, what are the numbers that go here, basically? That's what we're trying to find out. What numbers go there? We call these numbers, we can call them moles. We're trying to find the moles, basically. These are also called subscripts, right? So if I have C2H4O3, how many C's do I have? Good. I could say how many C's? 2 moles of C. I could say also what? 4 moles of hydrogen. And what? 3 moles of oxygen. So we want to get those numbers, so I'm going to change the grams to what? Beautiful. Moles. Simple. Okay, I'm going to erase this. So we're going to change these to moles. Hello. Good. Okay, I'm going to multiply by a fraction, right? I'm given grams. I'm going to times by a fraction. And again, what am I looking for? Moles. So if I'm looking for it, where does it go? Good. Moles on top, moles on top, moles on top. What am I canceling out? Beautiful. Goes on the bottom. Grams per mole, mole per gram. What is that called? Molar. And how do I get the molar mass? What's the molar mass of carbon? Beautiful. And where do I put that 12 number? What's the unit for molar mass? 12 grams per. So it's 12 what? And then what's the mole number? Good. How about hydrogen? Yeah, 1 gram per mole. Yeah, 1, exactly. And then oxygen? 16 what? grams. 16 grams per mole. You got me? You're with me? Now you divide all the numbers together. 40 divided by 12, what is that? I'll tell you. 3.333. Okay? Next one. Obviously, this divided by 1 is just good. And then 53.29 divided by 16. 3.3306. Do you think it makes sense for me to have a compound C 3.333, H 6.71, O 3? No, right? I wanted to get whole numbers and reduced. So I have to reduce these subscripts by dividing them by the smallest number out of these three. So out of these three, which number is the smallest?
3.3.
Which one? This one or this one?
The bottom.
Yeah, this one. Usually they're not that close, but they can be. So if they're the same, then you just use the one number. But 0 is smaller than the 3 here, so this one would be smaller. Make sense? So I'm going to divide all three of my numbers by the smallest out of the three. Does that make sense? Yes? What does this give me when I divide it? I have a box of calculators up there. You guys own phones too. Use your phone. I want you to practice doing it yourself. So I'm not going to be there to calculate for you. Good, but you know how to use it.
Yeah.
Okay.
I just love to do
No,
this.
wait, can you do a video about that? So no.
Depends on the calculator you're using.
It's the same, it's like a different brand, it's the same thing.
Okay. Well, if you have questions on the calculator during the quiz, I can help you. So 3.333 divided by 3.3306. Mm-mm.
1.0.
So what you got? You should have gotten this. Yes? 1.0. You see how I have...
Oh, I didn't click the zero.
You see I have these zeros here? I don't... The part's perfect. I don't care about any of the rest of them. What number is this? Perfect. Just 1. That means just 1. So go back over here, and it equals 1. Right? How about the next one? What is it? 6 point, what's the number? 6.71 divided by 3.330. Is this the number? I don't remember the number. Is this the number? Like that? Good. You see how there's a 0 there? That's all I care about. I don't care about the rest of anything else. What number is this? Just 2. So I go back over here. 2. Obviously, anything divided by itself is what? Great. So, in conclusion, I have how many carbons in my formula? How many hydrogens in my formula? How many oxygens in my formula? There's my final answer.
But I thought they couldn't divide by each other too.
What do you mean?
Oh, I thought they had to like divide by, I don't know.
Who has to divide?
Like I thought it would have to be like 4, 6, 2, like it would have to be like even to divide.
No. That's molecular. I'm looking for empirical, the lowest ratio, the most reduced. You with me? Let's say that this ended up being 2.5. What do you think I would do? Nice. Yes. Times it by a number to make it whole. Don't round it. So start from the bottom. 2.5 times 1. Will that give me a whole number? No. 2.5 times 2. Will that give me a whole number?
Yeah, 5.
Yes. Beautiful. If I multiply that by 2, I have to multiply that by 2, and I have to multiply that by 2. So my new answer would be C2H O.
So it doesn't have to be even?
No. It does not have to be even at all. No.
Will that be
Yes. There's a question like this one on the quiz. Okay, what if I gave you one like this, where I said 2.3?
Well,
Can't round it.
just do the same thing.
Right, so 2.3 times 1. Will that give me a whole number? 2.3 times 2.
No.
2.3 times 3.
No.
What does it give me?
6.9.
So the 9s we can round. Remember, the 1.00, we like that, right? The one, if we had like 9, or we had 1.9, the 9, we like that. We can round it.
Oh,
So that,
7.
so that would round, right? So we can multiply by 3 here, and it would round to 7, yes? So then, but I have to multiply everyone by, and then that's how I would get my final answer. Does that make sense? So the only ones that you can round, if you get 2.00457, whatever, or 1.968, whatever, as long as like it's a 0.9 or a 0.0, you can just round it out like that. Make sense? My final answer again is CH2O. Okay, now what do I ask you for molecular formula of this? So the next question might be this. Determine. Hello? Hey. I'm tutoring right now. What's up? I'm gonna probably leave after tutoring in like 20 minutes. All right. I will. All right, bye. Have a good day. This is how the molecular problems will look. Okay? So then you'll see a question 2, like the packet. Remember the packet? Determine the molecular formula for number 1. So this is number 1. When the molecular mass is 120 grams per mole. Okay? That's easy. It's asking us to find the molecular formula for number 1. Remember what I said. We can only find molecular formula when given the what? Empirical. Right?
Sorry, yeah.
No, it's okay.
Sorry about my-
So look, what does it say right here? Read it to me.
Cannot find the molecular formula without
Good. It's asking me for what?
the molecular formula.
Do I have an empirical? It's saying for number 1.
Yes.
In number 1, do we have an empirical?
Yes.
Yeah, we found it. This is our empirical. Does that make sense?
Wait, so in the test, would it be like a 2-part question?
Yeah. Like it would be built on each other, yes.
So there's 5 of them, so.
Well, it would be like 5, yes, 5 of them, but like 5 includes the parts.
Oh.
Like the packet. You remember the packet? It's the same exact build. Huh?
Imagine it was 10 questions.
No.
It'd be like 2.
No, you only find the I only asked for molecular formula for like one of these.
Wait,
Oh, okay.
and this one has to be even, right?
No, none of them have to be even. Stop thinking that. None of them have to be even. That's not a thing. Okay, so again, it says determine the molecular formula. We already established we can't find this unless we have empirical. We do have empirical because for number 1, we just calculated the empirical. Correct? Here it is. Here's what you need to do. Very simple. Take the molecular formula. That's what MF stands for. Molecular formula. Take the molar mass and divide it by the empirical formula. Molar mass. How do I find the molar mass of a compound? Add up all the elements from the table. But hold on a second. I don't have the molecular formula. How do I get the molar mass? It has to give it to you in the problem. It will always give it to you in the problem. Does that make sense?
Yeah.
So the top number for this will always be given to you. What's the top number? And I'm dividing by empirical formula mass. Do I have an empirical formula?
Yes.
Yes. Find the mass. 12, we said. Hydrogen's 1 times 2 is. And oxygen is. What does this give me? 30. Okay, so again, what's my empirical formula molar mass? 30. What's 120 divided by 30? Beautiful. It will always be a whole number. If not, you did something wrong. Or, if you get really close, like if it was like 3.9, that's fine. Okay, you're with me? Almost done. We're almost done. This is the easiest part. So I got the number 4. You're with me? I'm going to take this empirical formula.
Honestly,
Bye, have a good day.
thank you.
I'm going to take this empirical formula. And I'm going to take this 4. And I'm going to multiply every element by that 4. How many carbons do I have now? How many hydrogens do I have now? How many oxygens do I have now? There's my final answer. I'm done. Does that make sense what I just did? This is the molecular formula. Good? Any questions on this? Okay, I'm going to end the recording.